Good morning, everybody. Thank you very much, Gopal. So I'm going to talk a little bit more about how we drive advances in research transitions and advances in model evaluation. So research to operations, if you haven't gotten it by now, is very important to the Hurricane Research Division. And so we're building the bridge and then the highway. So here we have our two peaks, research and operations, and the valley of death between them. And we've worked really hard to build this bridge across that valley of death. And we have great vehicles like HFIP to deliver the research to operations. And as John touched on earlier, it's a two-way street. So we try to improve the operations, and then when we improve the operations, we can use that improved tool to then enhance our research going forward. And so we've successfully bridged the gap. There's still more work to do, obviously. So I'm going to focus on one particular project that's been a successful research to application transition so far, called Basin Scale HWRF, or HWRF-B. And this model is really built on collaborations. We've collaborated with EMC, DTC, RDH, PCS, and numerous other entities across NOAA. And so this features the multiple moving nests. So what you can see here, we have high resolution nests following our 3 hurricanes in the same basin. It's also a really, really large domain, so we can focus on multi-scale interactions. And we see improved performance with this type of model. And most importantly, as Gopal touched on, this is paving the way to the hurricane analysis and forecast system, because we can use this technology with multiple high resolution nests in the global model. So I'm going to walk through a sort of a Gantt chart here to show you the evolution of HWRF-B over the years. So I'll start in 2011 when HRD and EMC collaborated to get the 3rd nest, a high resolution nest, into the operational HWRF. HWRF-B was then developed with this multi-nest technology at readiness level 4. By the way, I'm showing the collaborations in the arrows. So those are the entities who collaborated on the development. For the last several years, since 2013, we've run HWRF-B as a real-time demonstration project where it's progressed from readiness level 5 to 7. Thanks to HFIP for that. We've also merged the community code. We've improved the data assimilation, and we've added dynamic ocean coupling to multiple storms. And currently we're working with EMC and DTC, among others, for an operational transition, an actual R2O project. This model is now sitting at readiness level 8. It ran as a proof of concept on the operational machine this year. These are the types of pathways that we want to follow with our transitions, taking it all the way from the infancy and putting it right at the brink of operations, and then actually helping our partners get it into operations if possible. So I'm going to focus on a few model evaluation questions that are important to us. And I think the most important thing here is we work with our partners at NHC to figure out what are important questions to ask. Where were the forecast failures? And then we dig into it. So first, looking at the value of multiple moving nests here, we ask the question, would Hurricane Isaac intensify or dissipate? This is sort of a messy graph showing deep layer vertical wind shear, where red is high shear. And here I've focused in, here's our high resolution nests again with the white boxes. And what we found is that outflow from Florence and Helene actually intensified the wind shear near Isaac, which tilted the vortex over and allowed dry air to entrain into the core, led to the demise of Isaac. So here's an intensity forecast for Isaac. Blue is the basin scale HWRF, red is the operational HWRF, black is the best track, what actually happened. So we see for this forecast, among others, the basin scale HWRF showed a big value getting that dissipation of Isaac, as opposed to the HWRF, which was showing a potential threat to US interests. So what we did is we took the nest away from Florence, and we said, what happens to the forecast? And we degraded back toward the operational HWRF solution. So we're showing a value of the high resolution forecast for Florence. It's not only critical for Florence, it's critical for the other storms in the basin, such as Isaac. So another question we can ask, looking at multi-scale interactions, is what's Hurricane Joaquin going to hit the United States in 2015? So we created an 80-member ensemble of HWRF-Bs, pretty much, and here's the spaghetti graph. And what we did is we split it up into good tracks and bad tracks. So we went in with the hypothesis that the vortex structure, especially the depth, was going to play a big role here. But what we actually found is that the vortex looked very similar. This is azimuthally averaged wind in our 2 composites, very, very similar. So when we dug into it, we found that, not surprisingly, but still interestingly, the environment was dominating. So the steering flow, in particular, this region of really weak steering called a call, was really, really critical between these 2 members. Between these 2 composites. And what you can see here in the yellow dots and black dots are the individual members, where you have either the members are too far west, so they're being pushed toward the United States, or they're right on that call or to the east, so they go out to sea. So we also like to look at improved performance. So here's our 2019 statistics for the North Atlantic from our real-time demo. And these are track and intensity skills. So essentially, if the blue line is above the red line, HWRF-B was better. And if it's below, then the operational HWRF was better. So you can see for both track and intensity, especially at later lead times, we're seeing a big benefit greater than 10% improvement for many lead times and intensity. So basin scale showing the value. So when we bring in this multiple moving nest paradigm, we're seeing the value, and that's a big step forward. And so finally, just real quick, the AOML Hurricane Model Viewer, we provide a tool for people to compare experimental and operational models in the same platform. So here you can go navigate to our website and look up a forecast for Hurricane Dorian from the basin scale HWRF. And we can actually compare that side by side with something from the Hurricane Analysis Forecast System and even the GFS. So we can do real-time evaluation to figure out where our gaps are and where our model failures and successes are as well. So thank you, and I'll turn it over to Shirley Murillo.